So thank you. Okay. So I need a reminder. How far did we get on Monday with our Foldar practice? Did we do blast off? We didn't do blast off. Okay, so let's start with blast off. So today, most of today will be again spent with practicing a few more Foldar things, and we will use Foldar on various kinds of data. So let's start with blast off then. Uh, so where I wanted to get last time was design a function which for any given number, the string 9, 8, 2, 1, blast off. Okay. So we will want to do something like this, and we will want to use Foldar to do this. Let me give a signature, which we give it a number, and it should give us a string. And we want things like 10, blast off of 10 should produce exactly this string. Blast off of 3 should give me 3, 2, 1 off. Okay, and zero should just give me no counting down. Okay. So, given my number, how can I use Foldar to define this function? How can I break this problem down? One, two. Yeah.
So the function you could use is string append.
So I could use string append somehow, right? We do need to generate a string out of some collection of numbers. Okay, so string append somewhere here, possibly with something else. You don't know yet. What else do we need? Josh?
So Foldar, so this abstraction, so somehow we need to get this dependence.
Right, so here we need a list of numbers, as Josh said. So Foldar is a list abstraction. We do have a number, but to use Foldar, we do need a list of numbers here. What do those numbers represent? Josh?
Is it possible to locally define a list of numbers starting from n and minus 1 all the way to 0?
It certainly is possible. How do we do that? Yeah?
Could define like it would be like a constant, like, or not a constant, a variable like blast off,
Uh-huh.
or not blast off, like countdown, which it like makes a list of numbers. It's like given a number, and then it somehow makes like a list of numbers with 10
numbers starting with n going down to 1, something like that. Okay. We have a suggestion online, and that is to create a function using build list. Okay, so we can use build list, and then I don't need to define this as a function. So I need a list of numbers, and then we can maybe use countdown here. Okay. So what I want here is a list starting with n minus 1, etc. to 1. And we got a suggestion that we can do this using build list. Parameterize with n. And the suggestion was to use actually sub 1. Now my question is, will sub 1 work? Let's say that I want a build list of 10, and I use sub 1. What will I get? Josh? Can you?
Wouldn't it be an error if you get the long list and would stop at 0?
No, it wouldn't be an error. Remember that build list takes in a function that takes a number and returns an element, right? Did you want to say? Yeah, so if we use sub 1, right, what build list passes into the function is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we get is basically just the list shifted by 1 into the negative numbers. Yes?
We make a function that we make a new function that it takes 10 subtracted by the number.
So a new function, let me call it, what does it do?
That would only work for numbers that are less than 10.
Yeah. So there is a suggestion going on online that we could simply use build list and add 1, which will give us the list in reverse order, right, that we need. And then I don't actually remember if there's a reverse function. And there is one. Yay. So we can do that. If we didn't have reverse, here's a little thing. Can we still use build list? Well, we can use build list, is the point. But what kind of function would we have to define? Josh?
It has to be local.
It has to be a local function, yes, that is true. But what operation does it need to perform? Here's a little thing. So I want to generate a list from n to n minus 1, n minus 2, etc., right? Up to 1, right? Where 1 is actually equal to n minus n minus 1. Right? Do we have a...
We create another local which subtract the index from n.
Exactly. Instead of doing sub 1 or add 1, we create a local which subtracts whatever is passed in from the number n, right? We start with n. The first thing that we get in is 0. So 10 minus 0 is 10. 10 minus 1 is 9, etc. We get to 10 minus 1, so 10 minus 9, and we get 1. So I'll just call it down. We need a function that takes whatever it takes in, as Charlie said, and subtracts. What did I say? Wait, no, I cannot name it the same number. Subtracts x from whatever we get in. Okay, because this is exactly 0. So that's the way we can do it without reverse. Okay, so now we have a list of numbers going from 10 to 1. We just need to combine it somehow into a string. We do want to use string append, as was suggested, but we need to do some extra work around it. And we don't have strings, we have numbers. Yeah?
We have to like include each number and like comma and space.
Yeah, so we need to have, so apart from what we actually want to do in each case is for each number in our list, we want to convert n to number and append it as n comma and space, right? So let's abstract that. And let me say, fine. And I'll actually make it simple. Let's do it straight from the number. So we need to convert the number to, sorry, vice versa. Number to string. Right. And we want to append it with a comma to what? Yeah?
We want it to be like somehow recursive to the next number in the list.
Yeah, so we got a list called countdown, right? And we want to somehow combine it by appending the numbers in the list together with the string blast off. Okay, so maybe the easiest thing to do actually is to decide what the base case here is. Right? If we have an empty list of numbers, as I said, if we give it 0, bitlist built an empty list, then we just want blast off. So maybe this is a good base case. Okay. Moreover, we are generating a string. That means that this needs to be a string. That means whatever we pass in here, whatever function we pass in here, needs to take in whatever the type of things here is, right? So numbers, and whatever the type of the base case is, and whatever the return type is. So a string, and return a string. Right now, I just have a number there. Yeah.
So you have to add like an input, like master, what we already done.
Yeah. So we need to append it to some. I will just call it str. Append it to some string, and then we have a function that we can plug in nicely. Into a folder. Yeah, Josh?
Can you explain the definition, the mental definition of down again, and how it's used in the
So the way down is behaving is whatever number it gets it will subtract it from the maximum, from what we count down from, right? Because build list will build a list by passing in numbers from 0 up to n minus 1. Down will always take the x, so for the 0th element, right, the first element will be n minus 0, because x will be 0 for the first one. Second element will be n minus 1, because the x passed in will be 1. Third element will be n minus 2, because x will be 2, etc., until we get to the last element, which will be n minus 1. Because to generate the last element of the list, build list passes in n minus 1, whatever we pass in as the number. So the last element will be n minus 1. Right? So if we have 10, we will get 10 minus 9. And that will be the last element. Yeah?
So if you did want to use down, could you just like say countdown, like define countdown and then just reverse build list at?
Uh-huh.
Okay, so it's just the same thing.
Yeah, so I could just use countdown could be as well defined by this. Okay, because we determine if we pass add 1, it will count from 1 to 10, and we just need to reverse it. So it's totally fine. Okay. This is just for sake of exercise. The other difference is, if you, not for very short lists, but this one actually first builds up the list and then reverses it, which is another operation that goes through the list once again. Whereas if we use down, we are just doing it in one go. Hey, let's see if this actually works. Of course it doesn't. Should be okay. Local here. Okay. Okay, we're good. Okay, so a variation on this. If we did it last time, I would leave you with an exercise to design a function that for any number n generates something like this, right? With the na repeated. So you can try to do this on your own time as a variation of on the above exercise. Okay, let's do another little exercise here. Let's do and design a function computes the average list of numbers. Okay, so I want to design a function called average, which takes in a list of numbers. Hello. And returns a number. Okay, now let's do a few examples. 1, 2, 3. The average of this one should be 2. If we want another one, average of 4 or 5. To make easy on myself, is this, and oh yes, 1 point. Sorry, let's do 3, 1.5. Okay, so something like this. do we need for this function? How do we calculate the average of a list? And again, I would love to use Foldar. Yeah?
We would do full R, and then we would sum up the elements of the list and then divide it about the length of the list.
Okay, so, sorry. So what we want to do is to use Foldar to sum up the list of numbers, right? We already did this. This was the literal definition of our sum function once we got to Foldar, and then divide it by the length of the list. Okay, to make it a little nicer, we could even say fine sum is 0, 1, and divide the sum by the length of the list of numbers. Okay. Nice and easy, very readable, very nice definition. Now again, for the sake of exercise, is there something that is a little problematic? Not for lists like this, but imagine that you need to average a list that contains hundreds of thousands or a million of numbers. Yeah?
Does it have to do with something like you have to apply the addition to like thousands of millions of numbers, so it probably takes up a lot of memory?
Yeah. That would be one problem, but I think like what I'm aiming at is how many times are we going through the list in here? We define a length function, right? Before we know how it's defined. How many times are we? Yeah. Yeah, we are going through the list twice. First time we sum up the list, so that's one traversal through the list. And the second time we are taking the length of the list, and that is another traversal through the list, right? Because we are just counting the number of consoles that we encounter on the way. The length, yeah?
So to only do it once, could you do it where, like, it's a folder that it takes, like, this, the average of the past bar and adds the next one?
Okay, so could we do it somehow where we would just calculate the average so far and average it with the next number, right? Something like this. So something like when we use the max, we simply use the max that took 2 arguments and we accumulated, right? So if we define average 2 numbers, x and y, right? And we have sum of those numbers divided by 2. So if we use this function, and actually let me define this as define v2 ln. We just use Foldar average 2. What is the base case for this one? Let's try 0, and let's check the same tests. Blah blah blah. V2. Okay, will this work? Should, right? Where did I check expect? Where did I put only 1? Here. Okay, we're getting some errors. So the first three ran fine. We had 1, 2, 3 here, 3 tests here, so they were fine. But the ones for these, we get different values. Yeah.
When you combine them, you're not accounting for the weight of the previous ones that are.
We are not accounting for the weight of the previous ones, right? If we do just the running average like this, we are considering all the numbers that came before the same weight as the next number that we are taking. So this is not the right way to approach average. Okay. Any other ideas? So how about we try to just go through the list once, but keep track both of the sum so far and also how many elements we saw so far, so that when we go through the whole list, at the end we have the sum of all elements as well as the number of elements that we saw. All right, so let's do that, and I will define a helper struct for that, because now we need to keep track of two things. We could use posons for that, but I will, for the sake of readability, I will define a new struct, and I will call it sum count, and it will just contain sum and count. There will be a lot of repetition of the words. Okay, and again, I'm defining average v3, v3, v3. Okay. So what we want is actually go through the list once, accumulate the sum, and
For the average V2, can you just give base case as empty?
the base case needs to be a number, since we are accumulating a number. Okay, so in there, let me just answer the questions before I go on. So for average V2, we cannot use empty, because the operation that we are doing is numeric, and we are combining and getting a list of numbers. And then there was a suggestion: store that in a post with X as index and Y as running total. Yes, so that's exactly what we are doing. So well done on suggesting that. Ruber. Okay. So, and in this way, basically what we want at the end, let me do local definitions, and we will do something in the end. Let me write it as this. So step 1, compute the sum and the length of the list. Step 2, divide the sum by the length of the list. Okay, so that's what we want. What we want to do, so we first need to compute the sum and the length. So I will say sum and length, and compute it somewhere here, right? As we said, we want to use fold, do just one traversal through that. So fold seems like an appropriate thing to use. Fold R with some function, some base case, going through the list of numbers just once. Now, what is the base case for this fold R? Yeah?
Would it be a sum count with the 0 and 0?
Yeah, exactly. So if we have the empty list, so the best thing to always think about is what happens if we just have an empty list. If we have an empty list, both the sum and the count of elements is 0. Okay. And now we need some function that takes in a number and a sum count and returns a new sum count. All right, so I will call it, let's call it define add sum count. Okay, and it needs to take a number and a sum count. And seems like it will need to return a new sum count. Let's count. Two things. So add okay. Yeah.
So basically what it's gonna do is it's gonna add n to the sum of the sum field of the sum count.
Sum count sum SC. Right. So
And then for
yep.
the count, it's just gonna be like add one.
Yeah, we just add 1 to the count of some. No, vice versa. Some count. Terrible name choices. Okay. So each application of this will take some previous sum count. So the accumulation that we have so far, it will add the current number to the sum of numbers in the sum count and add 1 to the count field. We run this using foldr on the list of numbers starting with 0 and 0. So at the end we should have the sum of all numbers in the list here and the length of the list or the count of elements, element count in the second thing. Now the only thing left to do is to give the final calculation, which is relatively straightforward. Take the sum count sum of sum and length. Okay, and divide it by sum count of sum. All right. Okay, let me comment out these ones. What was this was. So let's see whether the new ones, and we're good. Okay. So if you compare these, right, this one is definitely nicer. Right? And for most of the examples that we have here, like lists of 10 numbers, etc., it's really much better to define something like this, right? But suddenly when your task is, for example, to, I don't know, process the US Census data, right? And you're having a list of like tens of millions of numbers that you're averaging, for example, like average age of the population or something like that. Suddenly you might find yourself caring whether you are going through the list once or twice, right? And you might want to write a function like this that saves a little bit of work. It's arguably much uglier than the first one, a little harder to read, a little harder to keep track of, like, did we do this correctly? Is there some mistake, right? But it does save some time. And We will talk about performance a little bit more as we go through the course, but this is a trade-off that you will find yourself doing, right? Some languages actually will allow you to write something like this, and we'll do some magic underneath to make sure that you only go through the list once, right? But in many languages, you actually have to be very specific what you want to do and need to try out something like this. It's always good. So what I find I like doing is to first write the easy version, right? And if I find that my input data actually is quite big, then maybe do the ugly version and test them that they return the same results for both. Okay, yeah? Add sum count. Yeah, of course. So add sum count takes two arguments, right? It takes the current number in the list. We are processing a number of a list of numbers. And it takes the SC structure, the sum count structure, that keeps track of the sum of the numbers that we saw so far and the number of elements that we processed so far, right? And all it does is it updates the sum of the numbers that we saw so far by adding the current number and making sure that the current element is also counted, right? So we start with 0 and 0. If we go through this list, for example, right, this 1, 2, 3, we process from the right, right? Because we are using foldr. It's one of the times where I feel too short. So we start from here. We have 0, 0, right? Add sum count will add 3 to the first 0 and add 1 to the second 0. So the sum so far is 3 and the count is 1. Then we process 2, so add 2 to 3 because the sum so far is 5. And the count so far is 2. Go to this one, add 1 to 5. So the sum so far is 5. And the count so far is 3, adding 1 to that. And that's the first element. So what we get back is actually a sum count with 6 and 3. We divide those two and do whatever we want. Okay? All right. Any other questions about this average? Okay. Let's move on to a slightly more interesting example. So let's design a function which for a given height renders a Mayan pyramid with that number of layers given number. Okay. So what we want here is a function called pyramid, takes in a number and returns an image. And what we mean by a pyramid, so we don't want to draw it using semicolons, but for example, this is a pyramid of height 3, for example. Okay, I want to, because this was a problem in my previous section, we don't want to draw using semicolons, right? This is just a representation. What we actually want to do is use rectangles. Okay. So the height is in layers. So we have 3 layers here, so the height is 3. The width we can determine however wide each layer should be. And again, what I want to do is to use foldr to draw this. Okay. So let's take a few minutes and collect some ideas of how we might do this. How can we break this problem down and try to use Foldar? What do we need? Get a number of layers, and we want to produce a single image, not images. Any suggestions? Yeah?
That we should build it like top and down, like at zero there's like there, but one is at top level, and then that like is full the next layer. But like adding a layer to the first layer instead of going on
Uh-huh. So basically have the bottom layer, then the second layer, and so on. So we want to stack them. Is that or is that?
I would say place below because
Ah.
and then two and then three because there isn't a limit. I don't know if there is a cap, give it from, so it's easier to go the least number that can have, which is 0 or 1.
Mm-hmm. Okay. Yeah, that's a good overview. But still, how do we break this down? We have some suggestion online. Build a list that tracks the number of blocks in each layer. That's a good idea. Okay, so list of layers or layer widths. Okay. And Foldar with below creating rectangles. Okay. How about we break it down a little bit further? So let's build a list of layers, and then somewhere here use Foldar to draw layers, top or whatever. Okay. So here we want a list of number, right? Because we want a list of widths to represent the layers. It's kind of an abstract representation of the pyramid. Here we want an image in the end. Foldar wants a list, right? Yeah?
We could do like make a strong pyramid and then include the list that pulled on or the one thing that pulled on makes sense of that.
Yeah, we could do that. We could just simply have a function that converts a width into an image, or list of widths. Into an image or something. How about we break it down a little bit further? So how about we draw individual layers and we get a list of image, right? So we can do that. Then Foldar becomes relatively trivial. All we need to do is take the images and place them one over the other. So the last bit becomes very, very easy. What we need for this, though, is convert a width into a layer image, right? So we want a function that will take a width and return an image for that. Okay. If we have such function, what can we do with such function? Let's actually start writing this down. So we want a layer list defined using something. Right. Then we want to draw individual layers, so I will just use define image list from there, and the final thing that we will use will be to do a folder using something and taking in image list. Okay. And for this, we decided that we want a layer that takes a number or a width and draws an image for that. Number to image. Okay, let's build the list first. How do we build the list of widths or layers? Each layer is represented by its width, right? Yeah?
We would use build list of the given number, and then the function that we would use, you could write a helper function that just does 2 times the number plus 1.
Okay, so let's do helper. So, okay, of a number, and let's call it of n. And you suggested that we do, what was the computation?
2 times the number plus 1.
2 times the number plus 1, like this.
So,
Okay. Just quickly, why do we add 1 to this?
because that's going to be the one that's in the middle.
It's gonna be the one that's in the middle.
Is the top layer 1, the second one 3?
Ah, okay. Yeah, very good. Okay, so you take the layer, add 1 to it, but then, right? Okay, that should work. Times 2. We didn't define what we mean by the width, right?
Well, also I meant you add the 1 after you multiply by 2. But
Add the 1 after we multiply by 2. So this way
I think so.
is the one. Okay. Any other suggestions? The one thing that we need to agree on is what the width represents, right? Yeah?
So is n the, how many layers it is?
So n is whatever build list passes in, right? So if we are building 3 layers, build list will pass in 0, 1, and 2.
So I guess it was right before, like it should be 2n plus 2 rather than 2.
We should do n plus 1 because we don't want to have an empty layer. Okay, so that's why we actually want to do n plus 1. But coming back to my thing that I was adamant about is we didn't define what we mean by the width of a layer. Okay, so what we need to say is, do we mean blocks or do we mean pixels? Okay, and I would argue that for simplicity right now, let's just do pixels so that we have an easier time and don't need to write other conversions. Okay, so let's agree that, for example, a width of a single block will be 20, right? 20 by 20. I think that could work. So that would mean that we want 2 times 20, which is 40, plus 1, which is plus 20. Right? Am I doing the math right? Because like these units are blocks,
We're
right?
at 1n, then why is there also a 1 on the outside?
Good question. So this is the layer number, right? Build list starts from 0. We want to come from 1, so this is why we come from 1, right? Layer number 1 will be certain width. Layer number 2 should be what? 3 times as wide? Not really, right? Because this is not 3 times as wide. Okay. Yes?
Wait, so the first layer is like the top layer?
Yeah.
Okay.
So we want this one to be the top. And I'm starting to get confused with this math here. Okay, let me break this down. So this will give us the layer number, and I suggest that we simply say that each layer will be like 20 pixels times the number. We don't need to do it really exactly. Okay, let's start with this. Yes?
It's about the elements and the number of semicolons, then it's isn't it just starting with 2 and adding 4 each time?
Adding 4.
Yeah, 2 on the left side, 2 on the right side.
Yeah, adding 2, right? If the width of the block is 20, then it's the layer plus. So if I say the block is 20, then plus 40, is that the math? I really don't know anymore. That should be the math, right? We'll see. Let's just do something here. Let's draw the layers. Okay, so let's say that we have a width. Okay, how do we draw a layer? I suggest we just do a rectangle of the given width. So this is relatively easy. And I'll give it 20, solid, and let's make it brown, for example. Okay. So we have a list of layers. We know how to draw a single layer. How do we render a list of layers? How do we convert layers to images? Yeah? Exactly. We have a function that takes a number to an image. We have a list of numbers. What we wish for is a list of images. So we might as well just map the draw layer over a layer list. Okay. The last thing to do is to simply take the images and stack them above each other using foldr. So walk the list of layer images and stack them one over the other. How do we do that? Yeah? Okay. So we want to use above. Why above?
Does the list go 1, 2, 3, or maybe below? Because does it go from the smallest layer to the biggest layer, or the biggest layer to the?
I don't know, the answer is on there.
Oh, never mind.
Josh?
Do you like, I don't think there's a way to find something like reverse thing, or the
Okay, my question still is, before we go that way and kind of decide how do we define below if below isn't defined, do we use above or below? Let's say that we have a below, and then it's just a flipped version of above. Yeah?
Since build list doesn't start with 0, so like it would be list 0, 1, 2, 3, 4, 5.
Uh-huh.
So I think that would kind of answer the problem with does it go up like 10 to 0 or 0 to 10? 0 to 10.
Yeah, it answers the question. So how does build list behave, and what order do we get the layers in?
So it would be you start from the top and you go down.
Yeah. So, yeah?
Some sort of order.
So then if zero's on the list and our height, like say is 5, we want it 5 tall, and it has 0, we're adding 1, doesn't that have 6 layers? Or does build list not include the number, like the?
It doesn't include the number. Okay? We give it n, build list goes from 0 to n minus 1. That's what our function receives. Okay? So we agreed that the yeah?
Wouldn't it be above since it's folding from the right? So we would have like the base, like the one before the base, above the base, and then as you fold up, it goes above, above, above.
Exactly. So we have a list with the smallest layer in the front of the list, right? And the largest layer on the right of the list. Of course, fold-R goes from the left to the right, but the way that things are combined actually is from the right, right? So the first thing that we actually place somewhere is the last element. So we need to put the last element above some base, then the second but last above something else, and so on. And finally, we place the first element above the rest of the pyramid. Okay? So you were right. You explained it. We're good. Okay, now we have to decide what's the base here. So I think we can use just empty image, or we could just draw a wide rectangle that should cover the things. What is the?
I have a suggestion for that layer of an local function. It's plus 20 and star 40.
So to flip it, let's actually draw what we draw, and see where we go. I think my calculation is wrong, but okay. So we agreed we need to use above, because we are basically starting with the lowest thing and then placing everything above everything else. This was the height. Okay. Now let's try a pyramid of height 5. It's not the nicest one. It's okay. And your suggestion was to flip those two, I think?
Yeah, it's plus 20
Uh-huh.
star 40. Let the numbers, and no add 1.
And no at 1. Well, whatever. I mean, that's a big pyramid. It's not what I quite wanted to. That'll do. Okay. So regardless of the calculation, and like today is not a good day for math for me, definitely. What we did here is kind of broke down a problem where on the input we had some number, on the output we had some image, right? Broke it down into several steps, where each step was relatively simple. Just have a way of generating, based on the number, generating some list that represents the structure that we actually want to build, then converting whatever we use as the representation, so in this case the widths, into some sort of image representation, and then we can simply use Foldar to kind of combine the image, right? And because the ISL or the image library provides these convenient functions to simply combine two images and place above one over the other, the Foldar actually is pretty simple. What we do need to pay attention to is the order of operations of how we do things. If we did below, I think below actually isn't defined in there, but if we define below as the flip of those, we would get a reverse pyramid there. Okay. Okay. Are there any questions apart from drawing the layers? Because I don't want to deal with that anymore. Yeah.
Well, I was just gonna say, what would happen if you didn't have to add one in your function?
If we didn't have the add one, actually this would be okay because we are adding 20 to it anyway. So I think that would actually look nicer. Now that I think of it a little bit. Right? Because even if it's 0, we still add 20 to it, so we don't have an empty one. Hey, any questions about folders and maps? Okay, just a little bit. So we're out of time, but just a little remark about how powerful this combination of these list abstractions is. Okay, foldar and map. The other term for foldar in some like circles of computer science is also reduce. Now, has anybody heard about map reduce? So the action of mapping and reducing, aka folding, is what Google built their fortune on. Okay? So it's not that they invented these concepts, like mapping and folding was a known pattern or like a known idiom for a very long time. What they did is realizing that if you can express computational problems as a combination of these two things, you can build an infrastructure that makes these things run on massive clusters of consumer-grade hardware. Okay? So what they did is expressing all the algorithms that go through the internet, collect data, and somehow put it all together, representing it as MapReduce, and then basically throwing it at this infrastructure, which kind of maps some computation over a large amount of data and then combines them into other clusters. Okay, so it's a very, very powerful idiom. Not only it allows you to then allows you to express computation at a higher level. It also allows you to quite often to think, because you think more abstractly about your problems, to simplify these problems. Okay? Because there are certain relationships between map and fold, and between doing fold on a fold, doing a map on a map, etc., that allows you to optimize and allows you to run these kind of computations in parallel and combine them, right? You can imagine that before we do fold, right, if you map a function, so if we do this map draw layer to a width list, if this is a very complex operation on large amounts of data, these maps can be done on different computers because they are independent pieces of data that don't depend on each other. So we can convert them using different hardware and then just combine them bit by bit. Okay? So it's just something to think about about how useful these abstractions are. Okay, so thanks for bearing with me while I'm getting confused in here. Thanks for coming. Thanks for listening. I have office hours from 3 o'clock today. Otherwise, I'll see you all tomorrow. We'll do a little bit of local and learn something new tomorrow.